particle 1, A, B, C, D, E, F, G, H, E. This is another particle, yes. These are vibrating particles. Consider this to be vibrating particles along the wave profile, such that this particle is moving down, this particle here is moving down, this one here is moving down, this one is moving up, 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 down, 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 up, 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 down. I think we will end here, but if need be, we are going to increase to show these various vibrations. Now, if this particle is A, this is B, this is C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. Now I want you to take note. Particles at this point C, K, S are moving in the same direction. They are said to be particles in phase. They are in the same direction. Particles G, O are also in phase because they are moving in the same direction. They are moving in the same direction. Now, particle A and I are two successive particles which are in phase. Because this is E. E and A are neighboring particles, but they are not in phase. E is in phase with M. A is in phase with I and is in phase with Q because they are all moving in the same direction. B is in phase with J and is in phase with R. They are all moving in the same direction. F is in phase with N. They are all moving in the same direction. F is out of phase with H. I is out of phase with M. M is out of phase with Q. They are all moving in opposite direction. Now, we can also define wavelength as the distance between any successive particles which are in phase. Distance between any two successive particles which are in phase. And for particles to be in phase, there is one other point I didn't indicate. These are particles which are along the same horizontal line and they are moving in the same direction. Take note, this particle P, B is moving down and I is also moving down, but they are not in phase because they are not along the same horizontal direction. They are out of phase. They are not moving along the same horizontal direction. So if I draw a straight line like this, particle B and Q are in phase. These are two particles which are along the same horizontal line and they are moving in the same direction. If I take this rest position, this reference, A and I are along the same horizontal line, moving in the same direction, they are in phase. A and I are in phase and Q, they are all in phase. So the distance between any two successive particles which are in phase is also a wavelength. Maybe let me define particles in phase. In phase, P-H-A-S-E, they are particles along the same horizontal line, moving in the same direction. Along the same horizontal line, and they are moving in the same direction. They are along the same horizontal line, and they are moving in the same direction. They are said to be in phase. Particles that are along the same horizontal line, and they are moving in the same direction, are said to be in phase. So, Any two successive particles which are in phase, the distance between any two successive particles in phase is a wavelength. So the distance between between B and J is a wavelength. The distance between I and Q is a wavelength. The distance between H and P is a wavelength. The distance between C and K is a wavelength. The distance between G and O is a wavelength. A wavelength is also the distance between any two successive particles moving in phase. Any two successive particles which are in phase. To round up this first part of our lesson, we have looked at the definition of the wave summary. As a way of summary, a wave is a mode of energy transfer as a result of a disturbance in a medium or a field. We have said waves can be mechanical or electromagnetic. Mechanical waves need a material medium for transmission. Electromagnetic waves don't need a material medium. They can move in a vacuum. Examples of electromagnetic waves, you have light waves, radio waves. It's a whole family we are going to study. Then mechanical waves, waves on ropes, waves in water, sound waves, mechanical. Then we have looked at transverse waves, waves produced such that the direction of movement of the wave is perpendicular to the direction of vibration of matter producing it. Like waves on a rope, like waves in water as a result of a vertical disturbance when you drop a stone vertically in water. Longitudinal waves, these are waves produced such that the direction of vibration, the direction of movement of the wave is parallel to the direction of vibration of matter producing it. We have sound waves. We have waves generated on a spring by moving the spring along its length, by disturbing the spring along its length. We have also looked at stationary waves and progressive waves. Stationary waves are waves whose form moves, whose form doesn't move, stationary, whose form doesn't move, and progressive waves, progressive, they are waves whose form moves. Examples of stationary waves, waves produced on a guitar string, they are stationary. Waves produced by blowing air in a pipe, like produced on a flute, trumpet, they are all stationary waves. Progressive waves, water waves are progressive waves. Waves on ropes by fixing one end on a support and moving the free end up and down is also a progressive wave. Now we have gone ahead and we have defined amplitude as the maximum displacement from rest position, the maximum displacement of a particle from rest position, or the minimum displacement of a particle, maximum displacement of a particle below the rest position, maximum below the rest position. We have also gone ahead to define the crest as the maximum point reached by a particle above the rest position, and the crest, the trough, is the minimum point reached by a particle below the rest position. We have defined the wavelength as the distance covered by a complete wave, or the distance between any two successive crests or any two successive troughs. We have also defined the wavelength as the distance between any two successive particles which are in phase. Any two successive particles which are in phase. And we have also said, along a wave profile, particles along the same horizontal line moving in the same direction are said to be in phase. When are particles in phase? These are particles along the same horizontal line moving in the same direction. What else have we defined? I'm sure that is what we have done for now. When next we come, we'll be looking at the wave equation. And before we look at the wave equation, we're going to define period, we're going to define a frequency, then we will look at the wave equation and we do a few calculations for lesson number 2. Thank you and keep watching.